All right, so I'm going to be doing Rocketeer. I'm going to be walking through it. So to start, I'm going to draw the graphs, okay? Let's do this. So first, I'll be doing so I'm going to height, time, then the velocity graph, and then make that a little acceleration graph. All right, so just to start, we know that in this scenario that the person is going to be jumping off the building at 553 meters, and they get caught midway through their fall, and they land at 0, okay? So that's 3 separate events, okay? So event 1, jump, event 2, cut. Actually, I'm going to erase this, make this a little better. Event 1, event 2, event 3, jump, cut, and land. Ding. What the hell? What the heck? It's being frustrating. It's not an action. Oh my gosh. Cool. So then we know here, so if we're going to do this, starting at 553 meters right here, go here, and then they're going to be falling at let's make that a little better. They're going to be falling at a constant rate, which is gravity, increasing at that, until they reach the midpoint, which they get caught, and they land safely. See, they slow down. So that midway point is going to be around here. Actually, no. Wonderful. Around there. Okay, pretty much. At this point, they're going to be at 553 meters. So we're going to have to do H1, V1, T1 equals A12 equals H2, V2, T2 equals H3, V3, T3, A23 equals. Okay, so what do we know? We know the height is 553 meters. The velocity is 0. The time is 0. And we don't know height 2. We don't know V2. We don't know T2. Height 3 we know is 0 because that's where they land. Same for V3. The velocity is 0. Let's see here. We know A12 because they're going to be falling, so that's going to just be gravity, so 9.8 meters per second squared, or second per second, so meters per second per second. A23, we know that in the problem they just talk about how the Rocketeer has to be traveling 5 times the speed of the person falling in order to catch up, because they fall 5 seconds later, so 5 times gravity is all that would be. 5 times g, which equals, let me put that in my calculator. Yeah, we got it right, 9.8. Okay, oh. Okay, whoa, why did I write it like that? Equals 49, okay, that's what it says. Sweet. Awesome. And we don't know time. Okay. Now what? Okay, so what we're going to do next is draw the other graphs. So we got velocity here. Well, I'm going to draw the midpoints for every single one to make this a little quicker. Did not mean to do that. Cool. So we're going to have from here, well, that's acceleration. For velocity, we're going to draw, so we know it's, they're falling at negative 9.8 meters per second. Okay, and that's at a constant rate. And then they get caught, and then they start increasing until they hit 0. Okay. So he's pushing back on that velocity that they're taking at. Okay. So we know that's A1 and A2. Next, we got acceleration. So negative 9.8 meters per second right here. And then about 5 times that positive, because they got to move at a positive rate in order to come back up. Let's see here. So we got our graphs, and now we want to write out our formulas because we want to figure out what we need to solve for. So I'm going to change colors. Let's do blue. Okay. So first we know that we have both areas, A1 and A2. And so H1 equals A1 and A2 because of displacement. You know, the integral of that entire area of the velocity graph equals this total distance traveled, aka H1, 553 meters. So we can say H1 equals A1 plus A2. Awesome. Then with A1, we want to ask ourselves, how can we find area, right? Well, if we look at A1 right here, right, we can tell that that's a triangle, and same for A2. And so what's the area of a triangle? 1/2 times base times height. So that makes things pretty easy. So A1 equals base, which is that t value. So what would that be? Well, from 0 to that middle point is going to be t2. So time 2, that's where time 2 would be. So t2, oh wait, we got to write the 1/2. 1/2 times t2. And then what's the height? Well, because this is a velocity time graph, it's going to be velocity, right? And that's going to be the point until it intercepts there at the tip. And what would that be? That's going to be at event 2, and we know the velocity at event 2 is v2, right? v2. Cool. And then what's a2? Pretty similar. a2, so 1/2 times base times height. This time the base is going to be different, as here is where we're accounting for. And what is that? Well, it's not going to be t3, because that's going to be the total distance from 0 to that point. Or I guess we could say that's t3. So what is it? Well, it's going to be that second half minus the first half, right? Or not the second half. It's going to be the full amount minus the first half in order to get the second half. Okay, and what would that be? Well, that full amount is going to be t3. All right, and then that first half is t2, so minus t2. And we're going to multiply by the same height, v2, as they share that point, that side. Cool, so we now have those. Now, what else can we do with the information we have? Well, we know what's the rise and run of this graph. It's acceleration, right? So A12 is going to be that first half for acceleration. So what's A12? Rise over run, slope. And what does that equal? That equals V2 over T2, right? Because this is a velocity time graph, and we're accounting for A12. Then A23, what do we got? Rise over run, slope, as we want. And this time it's going to be V3 equals V3, but a little different. We're going to do the T3 minus T2 as this is the next half. Awesome. So we got some formulas. I like doing that, getting some out the way. Helps me really think about it better. I'm going to split them off in their respective areas. Cool. Now what? What do we want to do next? Well, we have A12 equals V2 T2. Well, with that, we can find T2, what the formula for T2 is, because we will have to find that eventually. So that would be T2 equals V2 over A12 using simple algebra. You just switch them around, right? So we got T2 equals V2 over A12. Then you're like, oh, well, we might as well find A23 as well, like T3 minus T2, and to find T3, right? So what we're going to do is we just switch around for A23, and we get T3 minus T2 equals V2 over A23. Awesome. So we got that now. Pretty awesome. And then we can also get T3. So T3 equals that, just plus T2. Fantastic. So we have those guys. Now what do we want to find? We want to find, well, let's see what we got. Well, we got all these formulas. If we look at H1, we got area. Since we started with that, maybe we could do something with that. So we got A1 equals 1/2. We got T2. Well, we know T2. We want to reduce the variables. So let's see how that looks when we write it out. So we got H1 equals 1/2 times V2 A12 well, to display it better, I'm not going to write that immediately. So here when we have base, right, or I mean area, we have 1/2 times base times height, which is going to be, so we're going to do A1 1/2 times T2 times V2 plus 1/2 times T3 minus T2, because we're now on A2, times V2. Awesome. So now what? Well, we know T2, right? So let's plug that in. H1 equals 1/2 times V2 over A12 times V2. Then plus 1/2. Well, we know T3 minus T2, right? So let's write that out. Times V2 over A23. Awesome. And then we multiply that by V2. So from now, let's just simplify. So, because we reduce that variable in order to solve these things, because we don't have T2, but we sure do have A12, right? So let's solve for V2 here, right? That's why we want to reduce to that. So H1 equals 1/2 times V2 squared, A12 plus 1/2 times V2 squared over A23. And what do we do from here? Well, to try to isolate everything, we're going to get multiplied by 2 on both sides, right? Because we have 1/2, we want to get rid of that. Okay, so what does that become? Well, I'm just going to write this way to save space. H1 what am I doing? Since we're doing it on both sides, it's going to become 2H1. So we got 2H1, which equals V2 squared over A12 plus V2 squared over A23. Cool. So, going over here, what can we do further? Let's factor, because we want to get V2 squared and to get, on its own. So to do that, we have to take it out of all these fractions. So let's simplify that. V2 squared, just factored out to be A12 plus, well, let's put it together now, might as well, plus 1 over A23. Awesome. So now what can we do? Well, we want to get those fractions on the other side, to isolate V2 squared. But to make it easier myself, I'm going to first make sure they're simplified to one fraction. Just makes it a lot easier. Equals V2 squared, then A23 plus A12 over A12 times A23. Cool. Now what? Well, we're going to multiply by the reciprocal of that. Okay? So what would that be? Well, we're going to multiply by the reciprocal because, we got to divide the fraction out, which is the same as multiplying by the reciprocal to isolate V2 squared. So let's see here. So that's going to become 2H1 times A12, A23 over A23 plus A12, right? And that equals V2 squared. Awesome. I'm just going to simplify that a little, make things a little easier on us. So that's going to be 2H1, A12, A23 over A23 plus A12 equals V2 squared. So now what? Well, we just got to do one more thing to isolate V2, and that's to square root V2 squared, right? So we're going to square root both sides. So we got the square root of 2H1, A12, A23 over A23 plus A12. So now we equal that to V2, as V2 squared is no longer V2 squared, and it's now V2 because we square rooted it. So now all we want to do is plug in numbers. So for this part, I'm going to change colors just to make it a little easier to read. Let's go over here. So V2 equals what? All right, so we know that V2, we got 2H1, right? So let's write our square root. What's 2? So 2. What's H1? 553. We know that. Pretty easy, one of the staple numbers in this. And what's A12? Well, we know that's gravity, as that's the first part of the graph, which is 9.8. And then we have A23. Yep, we got A23. And what is A23? That's 10 times gravity, and we can see that's 49 meters per second when we look back. So we're going to write 49. Okay, divide that. And what are we dividing by? We're going to be dividing by A23 plus A12. So that's going to be 49, A23, plus A12, which is 9.8. Cool. So let's plug this in the calculator and see what we get for V2. All right, okay, let's see. So V2 equals, what does this guy equal? Let me put this in my calculator. Jeez, why does it take a while? That's awfully weird. Okay, there we go. That will be giving us 95 meters per second. It's a decimal. I'm just rounding it, so make it a little easier. 95 meters per second. 95 meters per second. So, hey, we got an unknown. Look at that. That's a pretty big deal. It's awesome. So I'm gonna put that in. So we got V2. Let's put that guy in. Awesome. So now what do we want to find? Well, we got all this. Let's look at what we got. Well, we got velocity. Then there's T2, right? Let's go ahead and, find T2 since we have V2 now, right? And we'll probably need T2 later, so let's do that. So we got T2 equals, what's V, and we're going to do this in green, 95 over A12, which is 9.8. Don't even need to look back at that. Okay, just making sure, yep. T2, let's put that in the calculator. Okay, and another decimal, but we're just going to round to 9.7. Okay, cool. We got T2. That was quick. A lot quicker than the velocity, that's for sure. We got 9.7. And since we're getting T2, why not get T3? Let's not discriminate. Come on now. T3 equals, what does T3 equal? Well, we know T3 is going to equal V2 over A23 plus T2. And we got T2A, so we told you we needed it. So V2, let's get, 95. Over A23, which is going to be a little different. It's going to be 49, okay? 49 plus T2, which we now know is 9.7. So what does that equal? I'll redraw this guy's red. Because what the heck? There we go. Sorry about that. We got T3 equals, what is it? Let me put that in the calculator. Oh, another decimal. Just round to 11.6 seconds. Awesome. Let's put these guys in. So we got T2 equals 9.7. Got T3, which equals what? equal 11.6. 11.6 seconds. Awesome. So we got those guys. So what do we need left? Oh, well, only H2. All right, so how are we going to find H2? Well, let's think for a sec. Let's think. I've got to think. Okay, so to find that, well, we're going to need T2, right? H2 is the equivalent to A2, right? Because that's going to be the second height, right? Yes. So let's do that. So we got H2 equals A1. Cool. So what do we got here? We're going to have H2. Okay, H2 equals 1/2, come on now, times T2, and then times V2. Okay, H2, I get some more space. H2 equals 1/2 times 9.7, as we know, and V2 is, I can't believe I forgot that, 95. 95. All right. So what do we get when we plug that in? Let's see. Oh, that's going to be 461 meters. Look at that. Rounded up, but pretty much on the dot. Let's write that in red. Fantastic. Let's put this guy over here, since we now know it. Same displacement. Okay. Now we're going to move on to the next part. You might be asking, what's the next part? We're going to be moving on to the Rocketeer because we've been working on the student this whole time. So we're going to be tracking the Rocketeer's movement. So let's start with the graphs here, okay? So with the graphs, we know that the Rocketeer is going to be jumping off 5 seconds later, right? Well, let's draw that point, okay? Purple. Awesome. So we got that. Now what will we do? What we're going to do is we're going to first look at the first part and see what are we looking at, right? Well, we know that he jumps off 5 seconds later. We got that point. But in order to catch up, he's got to be moving 5 times the speed, as we talked about. So we're going to have to draw this as a steeper curve. Oh, geez. Need to make sure it's meeting up. Oh, no. Did I really just do that? Cool. It's going to be a little steeper than that, but it's pretty much it. And then what we're going to do now is we can see that distance that he travels. Let's go to the velocity. How is the velocity different? Well, the velocity is going to be different here because he's got to be able to catch them, right? And so his velocity is going to be much different at that point. So what we're going to do is simulate the velocity they're going to be going to meet them, right? So we got that. Awesome. Now what do we got to do? Well, then, what we got to do is now we want to solve some stuff, right? Well, since we solved area before, let's do that again, okay? We got height with that, right? So let's see. What's area of the Rocketeer? What is AR1? Let's ask ourselves that. What is that? Well, you're going to be like, well, that's going to be kind of hard because look at that. It's kind of a weird shape. And also, you would think it's that whole point, but no, it's just that sliver that we have marked out with the purple and black. We're going to be focusing on the velocity like we did before. So how are we going to do this? Well, we know that the area here is not just a triangle, right? It's a trapezoid, and that is going to cause us issues. So what are we going to do? We're going to split it into two pieces to make this a lot easier on ourselves. Around like that, right? Now what I just did is that we split this up into a rectangle and a triangle, right? That's pretty awesome because now what we can do is we can get the area of the triangle and the area of the rectangle, right? So let's do that. So what is that base? Well, you would say it's T2, right? Nope, it's not. You know why? Because he's jumping off 5 seconds later. So we got to subtract 5 seconds from that T2. So let's do that. So we got T2 minus 5. Awesome. And we got VR1, as that would be the height still. Cool. Now what's AR2? This one's going to be a little different. This is going to be the triangle, okay? I mean, yeah. So 1/2, same base. But this time, the height will be different. Just because of that difference for the triangle, okay? So with this, we can probably find H1 minus H2, right? H1 minus H2, H1. Yeah, because it'll help us get our value of VR1 and VR2. So let's do that. So H1 minus H2 equals T2 minus 5 times VR1 plus 1/2 times T2 minus 5 VR2 minus VR1. Fantastic. Let's mark it off. Cool, let's do this in blue, make it more fun. So what we're going to do is we're going to look back at that and just simplify that, you know, that guy that we just got. Okay? You know, that bottom rectangle right there. So what we're going to do is we're going to divide by T2 minus 5 on each side to isolate VR1 and all that other stuff further. So H1 minus H2 over T2 minus 5 equals VR1 plus 1/2 times T2 minus 5. That's what we got right there. Awesome. So now what? What do we want to do? Well, what we could do here, we still got to write. Oh, I missed. What am I doing? Yeah, I was like, what did I do? It's not T2 minus that. It's going to be VR2. What am I doing? Silly me. Okay. So now that we got that, we want to simplify, right? Because look at what happens when we simplify. Real quick, let me write this. What happens? Well, if we simplify that 1/2 plus 1/2 VR2 minus 1/2 VR1. Look at that. We can reduce our VR1. Isn't that crazy? So that's what we're going to do. So H1 minus H2 over T2 minus 5 equals 1/2 VR1 plus 1/2 VR2. Awesome. Look at that. That's pretty cool. So we got that. So now what we want to do is isolate VR1 even more. So what are we going to do? Something pretty simple. We're going to multiply by 2. Okay? Get these VRs on their own. So H1 minus H2 over T2 minus 5 equals VR1 plus VR2. Look at that. Now let's just subtract to isolate the VR, specifically the VR1. So let's do that. So, oh, and I forgot the 2. Oopsies. Let's do that. So I'm going to have 2 H1 minus H2 over T2 minus 5 minus VR2 equals VR1. Awesome. This is great because we have all these variables, but wait, we actually don't have VR2. And so you might ask, oh, how are we going to find VR2? Well, as we should realize that we can do something that we've been doing this whole time, and that is relating to other equations, okay? So we know that we can go off of some of these equations up here, and I think what would be a good choice would be A12. You might ask, why A12? Well, that's going to be velocity over time, isn't it? And so what's C? We're going to do our own version for the Rocketeer, though, as it is a little different. We'll write this little area of time to relate. Cool. So what would that be? Well, we know A12 is rise over run. What is that? Well, the rise here is VR2 minus VR1, right? That triangle. T2 minus 5. Then what's that next part? Well, A12. We're just going to get this, T2. Let's make some space. A12 equals, or not equals, what am I saying? Because right here, what we're going to write is we're going to go off of VR2 minus VR1, right? So we want to isolate that because we want to simplify our variables. So that will become VR2 minus VR1. Oops, not 2. Awesome sauce. Now what? We're going to have A12 times T2 minus 5 plus VR1 equals VR2. So we're just going to plug that guy in. That makes our lives a lot easier, right? Let's do that. So we go over here. What's going on? What we're going to do here is plug them in. Okay. Oh, get some space. Okay. So that what that's going to be is 2H1 minus, what am I saying? H2, yeah, what am I saying? H2 over T2 minus 5, right? Minus VR2, because that's what whole reason we solved for that, what we just did, equals VR1, the guy we are solving. Okay. So what are we going to do? We're going to go over here. Boop. And plug them in. Okay. It's going to be 2H1 minus H2 over T2 minus 5 minus, what is that going to minus? It's going to be, let's plug that guy in that we have, A1 half T2 minus 5 plus VR1. Does that equal? That equals VR2. Holy freaking crap. Look at that. Now we got variables that we can actually have. Oh. Did not mean to write 2 there. Oops. I'm like, yeah, we definitely don't have that. VR1. Okay, so what do we want to do? I'd say we should simplify, right? So let's do that. So what we're going to have here, well, what we're going to have is 2H1 minus H2. Yeah, 2H1 minus H2 over T2 minus 5, T2 minus 5 minus 1. Wait, why 1? Why would I write 1? I'm trying to think. Why am I... What? It's definitely not 1. Don't know what I'm saying. Let me think for a sec. What am I doing? T2 minus 5 minus... We're simplifying. Yeah, what am I saying? We're simplifying. Sorry about that. So we're going to do A12 T2 minus 5 minus VR1 equals VR1. So look at that. I'd say we can possibly get rid of that VR1. Hopefully. So let's do that. So what we're going to do is go over here. I have 2H1 minus H2 over T2 minus 5 minus A12 times T2 minus 5, which equals 2 VR1, right? Because all we're doing is adding VR1 to the right side, reducing that. But look at that. We got a 2 right here, a 2 right here. That means we're going to divide by 2. Pretty cool. I'm going to switch colors as we're getting close, I think. Divide by 2. So we got H1 minus H2 over T2 minus 5 minus A12 T2 minus 5. Okay. Oops. Equals VR1. Okay. I don't know why I wrote that. I thought I did something wrong. Now what? Well, what we're going to do, after doing that, how are we going to do this? We got the 2 out. Well, we divided by 2. I missed something. Guess what I missed? I missed the 1/2, right? Because we divided by 2. So, let me rewrite that part. Minus 1/2, A12, blah, blah, blah. All right. So now we got that guy. We got VR1. So we have all these numbers, don't we? So let's plug them in. About time, don't you think? Let's do that. Okay. I'm going to do this in green because I like green. So H1 minus H2, right? Over T2 minus 5. Oh, wait. We're plugging them in. What am I doing? I'm like trying to remember the variables for some reason. It's been a long day. Okay. So H1, 553. 553. What's H2? 90. Yes, sir. Because, as you know, we found that. Okay. Because we found that using what's it called? A relation earlier with the Rocketeer. So it's 553 minus 90 over 9.7 minus 5 minus 1/2 times 9.8 meters per second squared. Okay, because we got A12 right there. Times 9.7 seconds. Just writing out the variables right now. Why not? Minus 5, right? Because we got the seconds, T2, minus 5. Now, last of all, equals 76 meters per second. Look at that. That's pretty awesome. Plugged into the calculator. Let me write that in red. Give it its special thanks. I'm not going to redraw that line. I don't really feel like doing that. Equals VR2. Okay, awesome. So I think we just have one more unknown left to get, and that's VR2. Look at that. We're almost there. So I don't think this is going to take us as long. So VR2. When we look at all this, we see VR1. We got our A12 for T12 minus 5. Okay, so VR2. Do it correctly. I think, yeah. Oh, yeah. That's going to be VR1 plus A12 times T2 minus 5. All right. Got our acceleration, VR2, yep. Relating that equation. So now what we want to do, let's do in green, VR2. So I think we have all these. So we could just plug them in from the get-go. Awesome. So let's do that. VR2 equals 76, right? Yep, we just found that. Plus 9.8 times 9.7. If you know that from that, minus 5. Pretty easy, just look back when you see it right here. Okay, so what does this equal? Well, come on now. This is going to be 122 meters per second. Yeah, that's pretty quick. My calculator ain't so slow now. Awesome. So that's going to equal VR2. It should be all of our unknowns. We got VR1, we got VR2. Using our relating equations. That's pretty great. Then up here, we got all of our other equations, right? Look at that, H2, V2, T3, T2. That's pretty cool. Well, awesome. Well, I'm happy to find that and be done with the Rocketeer. Thank you, and peace.